Hello and welcome back to Creative Coding with Mutsi. Today I'm going to show you how to fit a P5 sketch inside a single tweet. That's right, the entire sketch fits inside a single tweet, 280 characters, very small code. This kind of stuff happens more often. I've seen it before with like Pico 8 or with WebGL, but I hadn't seen it before with processing with P5. And so I found this hashtag the other day. Actually, I found a very useful tweet by Komatebe, who explained that you can copy the code and put it in the P5 web editor and then see the sketch. So yes, it's part of a hashtag called let me get this right, tsu bu yaki Processing, which I believe tsu bu yaki just means a tweet, so it's like tweet processing, but in Japanese it's a Japanese thing. Alright, so how do we do this? Well, first of all, let me show you how to actually get this code to work. So you copy the code from the tweet, just this, not the hashtags, and then you go to an empty sketch, you put it in here, and then boom, it should work. Alright, if you want to have an idea of what's going on, you can click tidy code and you will see it is quite short. Also, it looks really weird. You got all these commas going on as opposed to semicolons. There's a bunch of brackets here and whatnot, and for some reason everything here is inside the for. We'll get into more detail later about how exactly all of that works. But yes, for now I want to show you how do you actually do this. So what happens is you take a sketch that you already have. So this one might be familiar from the from a previous tutorial I made. This is the golden ratio sunflower spiral. Alright, cool. So you take all of this code, and then you try and turn it into the smallest thing you can do. So this is basically does exactly the same thing as the previous bit of code. Then you take this code, you copy all the code, and you go to a minifier. For example, JS compress here. You take the code, copy it, and then you go to JS compress. I will put links of all of this in the description. No worries. Put your code here, click compress, and boom. Now you have a compressed version. So even though you already made the code as small as possible, this will make it even smaller. And even though this makes your code as small, makes your code really small, it will not be good enough to just take your original sketch and just chuck it in here. It will still be too large. Alright, well, then you take the code here, and then you go over to Twitter, and then you put the hashtag in, and you put the tweet in, you cross your fingers, and you hope that you have enough characters left. I've got one character left here on this one, which is great. If you're running out of characters, one thing you can do is you can remove the last semicolon there. That doesn't matter for the code. It still functions when you copy it and you run it. Another thing you might want to watch out for is if you put in the hashtag and you press like enter or whatever, what this is, it'll put an extra space there, like Twitter's trying to help you out with just your spacing. However, that space costs space, so you can remove it, and then if this thing comes up, you can either click away or you can press escape. Alright, and that's how you get everything inside a single tweet. Now, how do you actually make your code this small? There's a couple of things happening here. Alright, so this is one of the ones I made. First of all, with this one, as you can see, it's just a still, it's not animated, and so where you might usually set like a background, for example, black background, the word background is actually pretty long, it takes up quite a bunch of characters, and so in this case I opted for making sketches that have a transparent background. And this works. You can put these on Twitter. they work well. You got to watch out with like light colors so that it doesn't blend in with the light or the dark theme actually of whatever Twitter people are using. Yeah, so this has a transparent background. Funnily enough, you can see that therefore it's not exactly aligned. It's a little bit off, but yeah, we're not going to be too picky about that. Then, so here, because we're only, we're not animating anything, we can do all of the code inside the setup function. Technically speaking, I could do a draw here. However, because I do create canvas, doing draw means it would recreate that canvas every time, and that's a bit expensive. So if you need to save that one character, because it's one character less than setup, you can do it, but I didn't need it here, and I thought it was a bit cleaner. Alright, so yeah, we create the canvas here, then look at this little trick. Alright, what you can do is actually, look at that, even smaller. What you can do is you can define a variable, and the return value of this operation is the value that the variable got assigned to. So what this means is that you set a variable to 720, and then that will fill in 720 here as the first argument of create canvas, and then the variable s will be set, and it will fill in 720 here as well, and you get a 720 by 720 square canvas. One thing you might be noticing here is no let or var. In fact, for all of the variables, there's no let, var, const, or whatever. You can do that. Basically what it does is it makes it a global variable. It puts it onto the window object in JavaScript, basically. This is not great for code, obviously, but it does save a lot of space, and so you do want to do this. Another thing you might have noticed is that all of the variables are just one character. And I had to do this myself. I think in a minifier there might be ones where they do that automatically, so you don't have to like write your code like this. It will actually look at all the variables and then just give them random names. But the one that I found, or the couple that I found online, didn't do that, and it was an interesting exercise. It's also quite frustrating because if you don't exactly understand your code, it's not going to be clear by just turning all your variables into single characters. So that's great. So that's, yeah, and an agony in itself. You have to just pick a character every time, and sometimes obviously X and Y are logical. R here is for rewrite rules. Okay, that still works. A for angle. This one gets a bit more, and this is something to do with the size, I think. Anyway, so as you can see, it does make things more confusing. But what's also really cool is that because now you know that this is the entire code, it gives you like quite an oversight of like what the most compact version of the algorithm is. The fact that these are the rules that are necessary to render this thing. If you're wondering, this is an L system. These are like little rules, and you can make different ones of them. I'll show you at the end of the video the different ones I made. Yeah, and it just executes the algorithm here. Let's see, another trick. Yes, so here, let's see if I can explain this properly. I basically did the same trick as before here with the s equals 720. However, what's happening here is I'm drawing a line from the X and Y position, and then you take a step, so a step within the fractal, and then you draw the line towards the new one, right? You need a starting coordinates and an end coordinates. And so, because the algorithm then moves on from that other point, we want to update the X and Y value to have the new value. And for the longest time, I got stuck on this for a long time, trying to see if I could get it smaller, because I basically needed, like, after this, I needed to, like, fill in here the X and the Y, then the new X, the new Y, and then set the X to the new X and the Y to the new Y. However, I figured out that you can do it all like this, because basically what's happening here is that here the X and the Y have the old value, then here you set the X to the new value, and because of that same rule that we used here, it returns the new value, and the X is updated with the new value. Same with the Y, and boom, the whole thing goes in one line. One thing you see here, I've got save. If I uncomment this, it'll the thing will run once and it'll save a screenshot. You can use that to add it to your tweet. Makes it look nice. Let's see. What did I have? Yes. All right. So obviously you're doing a bunch of stuff, but the minifier is going to do some work for you as well, and that might be interesting. So this is the same one, but if we do tidy code here, then you can have a look at what it actually does. And what I wanted to show here is that this here is that whole if else thing that was going on before. Turns it into ternary operators, extremely sparse. Cool to see, cool optimization. If you're wondering about all of the brackets around here, that is actually a thing that happens because of the tidy thing here. So if you look at the original one-liner, well, I guess it's a one-liner. Everything is comma separated, which is an interesting choice. I'm not exactly sure why, because otherwise it would be a semicolon, which is still only one character. But there's no extra brackets around anything. Yeah, but when you tidy it, you get that. So, that's probably where I got these extra from. Anyway, yeah, so you can remove stuff like this and it works. Funny one with this sketch is here. I've got the color medium spring green. This is obviously a ridiculously long name for a color. The other iterations that I made of this one were a little bit more, took more space, and so I had some extra space here, and I was like, haha, I'm just going to use a ridiculously long name for the color. But if you can just say red, and it saves you a lot of hassle. Not as pretty though. Actually, not that bad. Okay. Cool. Let's see. So then, I made more. So there's some more tricks I would like to show you. This one, yeah, classic wave screen. Basically what the thing does is, you have a for loop where you go over each line, and then for each line you go over each line segment. So there's 99 segments in each line, and they can all move up and down to form this pattern, right? And so, first thing you might notice is this one is animated. And here, because we're using the draw function, it might be interesting to explain what's going on here with the draw function anyway. So again, instead of like doing var or even function or whatnot, you just say the word draw. It works. You do equals. You do an underscore here or whatever character you want, because normally if there's no arguments, you would do this. However, that's 2 characters and this is only 1 character. So you're assigning the argument that doesn't exist to the underscore. Yes, saves you another character. Alright, because we're animating, we want some time, right? So we start with t equals 0. And because we're in the draw function here, we need to create the canvas, but you don't want to do it every frame, because that's expensive. So what you do is, you say t, yeah, so what happens here is, the OR operator works by looking at the first value, seeing if it has a truthy value, as it's called, or falsy, and when it's truthy, it returns that object, but if not, it will return the other one, the one next to it, so the create canvas. Meaning to say that when t is 0, which is on the first frame, it has a falsy value. T equals 0 will give you false in a Boolean operation, and so then it will go to the second bit, do the create canvas. Set this up, same trick as before. Oh my god, I could have like saved 2 characters there every time. Wow. Oh well. And then it only creates it on the first frame. And then here we increase the t and it's not 0 anymore, and so this will return true and it will not call create canvas again. Haha. Because we're animating, we do need to draw a background. And so, yes, and for this one, you might think, well, wouldn't a black background be smarter? Because that saves you 2 characters. However, on a black background, your strokes don't show up because they're default black. And so if you put this on white, you don't have to do the stroke. What should you do? If we do these at 255 and this one at 0, then looks nice, but a bunch more characters, right? So because we have the word stroke here plus the 255, and instead we just do it like this, and then we do the default. That leaves you with another thing, that the default stroke weight is 1, and for a lot of videos, stroke weight 1 is just not good enough. It's going to get completely mangled in the compression. It's not going to look good. There are times you can pull it off, and sometimes you just have to deal with it because the word stroke weight is ridiculously long. It takes up a lot of space. So if you have the luxury of having your code turn out small enough that you have that you can put that word in there, you can use it. But that's kind of one of the things with this. Is it's interesting to see you have to work with what you got, and sometimes it actually creates interesting visual effects where it just looks different than what you had before because you removed something and actually looks quite interesting. Let's see. Yeah, what I wanted to show with this one is that, so as I explained, it's basically a double for loop. So you have, for each line is a loop, and then the line exists out of 99 segments, and so that is a for loop as well. However, here you only see one for, and it's badly indented. All right, there you go. Oh, small thing. Why 99? Because you probably want something like 100, but 100 is one extra character. So that's a nice way to save a character. Doing 99 instead of 100 usually doesn't really matter. All right. So what do I do here? Instead of doing a double for loop, where you do like x equals 0, x is lower than with x plus plus, and then for the y the same, but with the height, we just do a index, and that goes over every possible thing, and you do that by taking w times w, which will be the amount of iterations that would have run if it was a double loop. And then what you do is for the x value, you take the index, you do modulo the width, and then it gives you the x value back. Now for the y value, I managed in this bit of code, and this is part of the reasons why it doesn't make it much clearer, right? So in this bit of code, I managed to get it out here because it's supposed to be floor I divided by w. That's how you get the y value when you have an index like this, because basically if you do, because the w here is basically the size, because the width and the height is the same, and so then if you take the index, you divide it by the size, and you floor it, you actually get the y index. Then I divide that by the w again to get a relative, or get a normalized coordinate, I guess, and then that's what I put here in the function, and this function gives you back this whole shape and everything. But yeah, that's how I use that. And then here, to update the time, you add something to it, and instead of using like, what's the usual one, like frame count or something like that, which again is a very long word, you can just increment it with a small amount, and then you can change that to affect the timing. Yes. All right. Let's see. And then the last one I had here, I can't really leave this running because so this was the biggest challenge of the whole thing. This one is gonna keep doing this, and then it's gonna crash my CPU. So I'm gonna turn it off. But yeah, you might have recognized the sketch. I did a tutorial on this before. It's the fractal n-gon. And cool thing with this is because it's so dynamic, or however you want to call it, it's an n-gon, so you can up the n, and then you can see all the other ones, one for the square, for 4 sides, one for 5 sides, and I took each of these separately and put them in my tweets as what was it, Tubuyaki tweets, yes. Something like that. Alright, so what I wanted to show off here, because this one was really like, I really wanted the thing to animate. I wanted to be able to show the animation, and for that to work I needed this minus z times k and this times k here and this k here. So actually that might be good to show. What happens here is k equals min d of a half, and the animation here actually is stunted. It goes up and then it stops. The original, which you might know from the video, is like this, where it just continually keeps doing the thing. But I could not find enough space to put all these characters in there, so I didn't, and instead I found this, which has the same effect, but it looks a little different. Anyway, very happy when I found this. I think interesting to see here is that before I had the luxury of saying timer plus equals 0.001 or whatever, but that's already too many characters. So instead what I did is I just did plus plus, so that it goes up one integer at a time, and then when I use the t value, which is here, I divide it by 99, which again is like 100 but like smaller, and that would like make the animation go at a rate that was reasonable. However, I did not have enough space to put a modulo somewhere so that it wouldn't like go into eternity, you know what I'm saying? Anyway, that's what the tutorial is for. Show you how to do it properly. This is more challenge, how to get everything in there. Now, I think the sickest thing what I did here was, here's a function that gives you the coordinates, x and y coordinates of, when you go around the circle, basically. So you use the sine and the cosine for this. Interestingly enough here, I turned these around, for a visual choice, but that's yeah. However, cooler is that I put them in an array here, and usually you would just put them in an object and say, hey, the x value is this, and the y value is this. But as you can see, there's a bunch more characters, right? I need y colon, x colon, I need the extra brackets here because otherwise JavaScript doesn't know if it's actually a body of a function or if it's an object that you're returning. However, you don't have that, well, let me just undo. You don't have that with arrays because they're just, yeah, because of the characters used here, the square brackets. Anyway, what that means is then what you return here, before this, instead of getting two values back, the x and the y, I call them a and b here because I ran out of x and y. I think I used it. Turn it into, would otherwise just be like a point. At that point, you would get the x value by saying p.x, for example, and p.y. That is already 3 characters as opposed to 1. And here, okay, fine, then the destructuring of the a and the b is a bit more, has more characters than the initial p, but then the more often you would use these values, the better it would pan out, because then it would, otherwise it would take 3 characters and now it only takes 1 because you've got the a and the b. And did I mention that the variables are global, right? So in this case with the for, because we're going into a fractal, I couldn't actually not have this be a global value because I need this to iterate and retain its iteration value, while within the iteration it has a new one. So in that case you do need let or var. I mean, it's the same, right? What you can see here as well is that instead of doing the normal iteration and then getting the f value by taking the index divided by the count, I did that within the loop. So we started 0, 1 is the max, and you just add, in this case, a third. I hard-coded it because doing variables actually takes more characters. So if you say, hey, I don't know, v is a third, and you put here v, and then there's another one, you can put v. This actually ends up with more characters. You wouldn't believe it, but yeah, these are interesting considerations. Yeah, loads of fun. Learned a lot from it. I definitely recommend it. As for how to record the video, I will do that in a separate video because that takes a bunch more explaining. Yeah. Anyway, I had loads of fun with this project. I put a bunch of them on the hashtag. So we got the different n-gon fractals here, and yeah, all of this is just, all the code just fits inside the tweet. Hell yeah! And then I got this one. This one was the most satisfying because it's basically visually the same. It's because as a render, it was kind of the simplest of the bunch. I did some wave screens. I had some variations here. This one turned out a little dark. Oh yeah, and these are the L systems. So this one was actually cool because I had enough space here to color it, which I didn't have enough space with the other ones. It's dynamically across the range of the whole thing. Yeah, drag and curve. Yeah, you get the Sierpinski triangle and obviously the Hilbert here. Yeah. All right. Well, I hope you learned something. Please feel free to put some of your Tsubyaki processing tweets in the comments. I'd love to see it. And yeah, let me know if you make something cool with it. All right, bye.